day 6 of Data Science and AI add-on certificate course with industry internship. Thank you for joining today. As you know, I am Alphy Mathew, research engineer at IPS Solutions Limited. So today we are continuing with day 2 of our machine learning session. Welcome once again to the day 2 of our machine learning session. So I will share my screen. Okay, is my screen visible? Please confirm in the chat. Put yes if visible. Okay, fine. Thank you. So, we are in, as you know, we are in the day 2 of our machine learning webinar series. So, yesterday we explored the basics of machine learning and we walked through the entire machine learning workflow from understanding the problem to preparing the data and building the model and evaluating the model. So today we are moving into hands-on learning. Okay, so we will take the data pre-processing steps we discussed yesterday and we will apply them to a case study. Okay, so get ready to explore, experiment and learn by doing. So we can get started. We have learned all the basic steps of machine learning workflow, that is collecting data, pre-processing the data, then splitting it into train and test set, and then training the model, then afterwards evaluating the model. So we got a theory idea behind all these steps. Now we are going to apply everything hands-on on a case study. So our problem is banks receive thousands of loan applications. Okay, so they need to decide whether to approve a loan or reject a loan. I repeat, banks get thousands of loan applications, and our problem is to decide whether to approve the loan or reject the loan. That is our problem. So what do you think, what type of problem is that? Classification or regression? Very easy question. Classification or regression? Put it in the chat box. Just C for classification, R for regression. Yes. Classification. And we will be focusing on classification throughout this ML session. Fine. So we are going to build a classification model that predicts loan approved or not. If loan approved, then it will predict us. If not approved, it will predict no. So to make predictions, what we need first, most important thing, what do you think, what we need first? What is our first primary requirement for that? Yes, data. You need the data. Okay. So machine first needs experiences to learn just as humans. So we need the data set. So you can either download data set from Kaggle. Yesterday I have shown you how to take account in Kaggle and etc. So the data set we are dealing with is also available in the Kaggle. You can just keep in track of this Kaggle link. This is the data set we are using throughout this webinar session. Either you can download it from here or you can download this from our drive link. Okay. Okay, I will keep both the links in the chat box. Okay, there are two sources. From anywhere you can download the data set for our case study. So looking into this data set, you can see so many rows are there, and also so many columns are there: loan ID, gender, married, dependents, education, self-employed, applicant income, co-applicant income, then loan amount term, credit history, property area, and a loan status column showing whether the loan was approved or not, Y for yes and N for not. So this is the snapshot of our data set. So we now have our data set downloaded with us. Next, we are going to look into the features, the attributes of the data set. We need to understand about the data. Okay, here in our data set, there are 13 columns. Okay, 13 columns. In data set, we call columns as attributes or features. So this is a labeled data set. You can see that the loan status is our label, like yes or no. That is what we are going to predict. So along with the input, the output label is also given. So this is the labeled data, and for this data, our labeled target or the output is the loan status column. So let us look one by one what each column is or what meaning of each column. First column is the loan ID column. Okay, first column is a loan ID column, and loan ID column means is just a unique ID assigned to the loan application. Like we are getting some roll numbers for our students, etc. Like that, just a unique ID to identify the loan. Second column is the gender column. You already know what it means. Whether the applicant is male or female. Just going to the data set, you can see that. Second column will be the gender column. It has male and female values. Then third column is married column. It express or it shows if the person is married or not. If yes, then the person is married. No, then the person is not married. Then next comes the dependence column. So dependence column means it tells whether the applicant, the one who applied for the loan, it is called the applicant, whether the applicant has dependents like number of children or number of family members who are relying on that particular applicant. If it is suppose in the second row, it is saying that this corresponding male is having one dependent, means for him in his family one member is relying upon him. So that is the fourth column, dependence. Then coming to education column, it shows if the applicant is graduate or not. If graduate, the value will be graduate. If not graduate, value will be not graduate. Okay, so it gives a idea about the educational background of corresponding applicant. Then coming to self-employed, it means that or indicates that if the applicant runs their own business, if he or she is a businessman or not. Okay, so if yes, then he will be a businessman. If not, he is not a businessman. Then coming to applicant income, means income of the applicant. This is general and it is direct meaning applicant's income. Okay, annual income is given in that. And also next coming column is the co-applicant income. Co-applicant income means income of another person applying along with the main applicant. Okay, if somebody is applying loan along with this main applicant, then income of that particular person. That person may be the spouse of the applicant or maybe any other family member. So the income of that particular person is the co-applicant income. Then coming the loan amount. Loan amount means how much loan the person is asking for. That is the loan amount. Okay. Then coming to loan amount term. Loan amount term means number of months in which the applicant will repay the loan. Okay. It is the number of months where the applicant will repay the loan. Then coming to the credit history. Credit history means that the values are going it as 0 and 1. Credit history means it's simple. It shows whether the applicant has repaid previous loans properly. Okay. Do the applicant have a good credit history? If the applicant have paid the loans, previous loans correctly without any fail, then he has a good credit score and he will be having the score, means the column value as 1. If it is 0, it means as he is not having a good credit history. Okay, that is the credit history column, which shows the applicant has repaid previous loans properly or not. Then coming the next column, property area. This is the location of the property. The property, whether the property comes under rural area or urban area or semi-urban area. So this is the second last column, and the last column, that is our result column or the label column, which says whether the loan is approved or not. If loan is approved for that case in previous experiences, then it will be Y, yes. Then if not approved, then the column is denoted by N. So in summary, this is our data set. This is the meaning or a general domain knowledge about our data set, and it has 13 details that help bank, that is our machine learning model, to decide whether a loan application should be approved or not. Okay, so hope that you got an idea about our data set. Now we are going to start practical side using, we are going to make what the pre-processing steps, etc., what we studied yesterday into this data set. For that, we need editors, right? We need editors and programming languages to do all the steps that we have studied yesterday. So we will be using Google Colab. Do anyone know about Google Colab before? If yes, just put yes. No, just put no. Familiar with Google Colab? Yeah. Yes. Another no. Okay. Yes. Okay. Majority are no. 2 verses are there. Okay, fine. Google Colab is just free to use, and it is a Python editing platform. So only you want is a Google account and an internet connection. With a Google account and an internet connection, you can use Google Colab for free. Collab in the sense Google Collaboratory. Okay, so it's very hands-on. It's very easy to use, easy to share. Once you will working with it, you will understand that. Okay, so to open the Google Colab, what you want to do is just go to the Google and search for Google Colab. Okay, Google Colab. So go to the first link that you are getting. Okay, click on that. Okay, you will get something like this. Here in the left bottom, you can see new notebook. Click on that. Okay, it will take some time. Okay, this is our Google Colab notebook file interface. Okay, so one important thing to remember is that whatever notebook you create in the Colab, whatever notebook you are creating, it will be automatically saved in your Google Drive. Okay, it will be automatically saved in your Google Drive. So for the second time or for the next time when you want to take this one, you can search this in Google Drive. For example, suppose I am going to rename this file as to identify it as we can give it as today. So to rename that, very simple. You can see here untitled2.ipynb, you know. So just edit this untitled2 only. Okay, I am just editing today, just to identify that. Okay, today.ipynb. Okay, do not delete or do not rewrite this extension ipynb, only edit the name of the file. Okay, then where you will find this file later or the next day is that just go to your Google Drive. Go to your Google Drive. There you will be having a Google Colab folder. You will be having a Google Colab Colab notebook folder. Open that folder. In that folder, all your Colab notebooks will be there. Okay, our today is there. Look, the second one. Okay, today.ipynb is there. By double clicking, you can open it. And for the second time, if you need to create Google Colab in this location also, you can right click, then choose for more Google Collaboratory. So anyway, you can create Google Colab. Either go and search, then create a new notebook, then go and look in the Colab notebook folder in your drive, it works fine. Also, coming to your drive location, right click, more, Google Collaboratory, this also works fine. So there are two ways, any ways you can use what Google Collab. Okay, so this is the way we need to open Google Collab in the using your email ID. Okay, next, before we starting the coding, we can organize our Google Column. We can give headings, we can give in subheadings, we can download Google Column. Many features are available using the Google Column. So first we can rename the Google Column as with our project name itself. Okay, suppose our project name is loan approval case study. So I'm just renaming it as loan approval case study. Okay. So just to rename, what to do? Just edit the name of the file and just either press enter or change the control of the mouse. It will be automatically renamed. Okay. Now to add a heading or a title in the notebook, what we want to do is you can add a text. Look, this one, text. Click on that. Now type hash space. We can give a heading as what our case study. Okay, simple heading on loan approval prediction. Okay, now we have given a heading. So what we have given is that we are giving the main heading. If we want to make a text as main heading, what we want to do is give a hash, one single hash and a space. Okay, if we want to make it bold, then select it, make it bold. Okay, your preview will be available here. Then when you change your control, you can see one heading have been here. So remember that one hash space means main heading. Okay, if we want to add a subheading below this, what we want to do? We need a text below this. So place the control on this text and add another text from here. Add a text cell. Click on that. Then again, subheading we can add as suppose the subheading, give it as hash space. What will be the subheading? Suppose we can say it as import libraries. Okay, import libraries. Now it will be act as a subheading. Look, we can group this cells, etc. There are many features available in Google Colab. So we will be discussing only one or two. You can explore and you can research it on and find many features. So we can add images, add bullet points, etc. And we can make it as a complete fresh documentation as very very presentable documentation. So using this Colab also. Okay, so we have seen how to add main headings, how to add subheadings, etc. So these both cells are text cell, and in this text cells we cannot give any code. Okay, we are going to code using Python, right? So for running the code, we need the code cell. For that, I need a code cell below this import library. So click on the import libraries and go to here code. Okay, code. And this is a code cell. Here we can write the Python code. Okay, suppose I am just giving a print statement to print, suppose hello world or what. We can print as welcome. So to print something in Python, what we do is print round bracket inside the bracket within the codes. Give the statement you need to print. So this is a code cell, and when you want to run this code cell, you have the play button here. Okay, click on that. So for the first time, when you are running the cell in the Colab, it may take some time. Okay, for the first time only. Otherwise, it will go one by one very fastly. So it would run and you got the output here, welcome. So this is how we are arranging the Colab. So we will be focusing on coding, and we will be adding coding cells. When you try this, or when you submit your task in the LMS, make sure to make it in a presentable form, adding headings, making italics like that. You explore this text and submit a collab file, which is very interesting and presentable to see. Okay, so this is automatically saved. What we are doing will be automatically saved in your Google Drive, that collab notebook folder. Okay, then you can download this. For that, you can go to File, then download IPYNB. When you click that, the collab notebook file will be downloaded locally. Okay, if when doing task in LMS, when we ask to submit IPNB file, what you want to do is go to your collab, click on file, download IPYNB, then the IPYNB file will be downloaded to your local system, then you upload that in the LMS. Okay, also you can make it as PDF. If you go to print, then you can make the PDF part like this, exactly as a PDF document. Also you can do that. Anyway, you can download it and submit in the LMS. This is an overall idea of Google Colab Notebook. Okay, so I think you got a basic idea about Google Colab environment, code cell, and running the code cell, etc. So we are starting to code. For example, we can first import a main library we want, and we are going to import as import pandas as ed. Okay, I am going to run this cell. I am running it. Okay, I have run that. So the first library we import is the pandas, and in this line we are saying our Python to load pandas library to the Google Colab. Okay, then what is this pandas library? Pandas library is the most useful library in Python, which is used in data analysis and manipulations. Okay, it is one of the most popular data science library. It allows us to load data from files like CSV file, Excel file, and then SQL databases, etc. So what we downloaded before was the non data set is a CSV file. So in order to read that CSV file, in order to view that CSV file, to clean that CSV file, or in order to analyze anything, filter it, for many applications, we have many functions, many tools available in this pandas library. So you can say this as we have given as PD. Okay, as PD, import pandas library as PD. So it means that here we are giving a nickname to pandas. Okay, we are giving a nickname PD to pandas. Instead of typing pandas again and again, we type PD. So wherever we need to refer pandas in the upcoming code sections, we only refer what? PD there. Okay, so it's just like we are saying to Python that import the library pandas to the environment and call pandas library as what? PD. Okay, this is the first step. First step we are going to do. Now we need to load the data set into our collab. This is the second one. So I can add another code cell. Click on that code cell. Okay, well, I am giving it as loan. You can give any name. Okay, I am giving it as loan underscore data equal to pd.read underscore csv, just a function. Okay, so this is the function. Read underscore csv is a pandas library function that is used to read CSV files. That is used to read CSV files. But you know that our CSV file is located in our local system. It is not in the collab environment. So what we want to do is we need to upload that CSV file you downloaded from Kaggle or from the drive link anywhere. The downloaded CSV file must be uploaded to the collab environment. For that, go to the left side. I think you can see this. Here a folder button is there. Look here. Click on that. there, the first one, upload button. Okay, click on that. Now your folder will be opened. You choose that folder and choose your downloaded dataset. Okay, then click on OK. Now that dataset is downloaded here. Downloaded dataset is uploaded to our what collab notebook file. Okay, so remember before running anything, make sure that your dataset is uploaded in the collab environment. So now I have uploaded the dataset, the loan approval prediction.csv dataset here. Now you want to copy paste the path of this file inside this quotes. Okay, for that, click here in the three dots, copy path, then paste that path inside the bracket with quotes. Okay, now we are seeing to Python that please read the CSV file in this location and load that content to loan data. Okay, I am running this. When I run this, what happens is that the entire data in the CSV file will be read by the Python using the pandas library and it will load to loan data. Okay, then the data structure of this loan data will be data frame. You remember data frame are just like a table with rows and columns or Excel sheet like that. Okay, in order to see this one, suppose if you want to see some observations or some data or print some data, what we can do is again add code cell. We can give it as our complete data set is in the variable this loan data, right? So we can give loan data dot head. Okay, this gives first 5 observations of the data set. If I run that, I can see first 5 observation means first 5 rows, 0th one, first one, second one, third one, fourth one. So first 5 rows of the data set I can see from using the function loan data dot head. So if we need to find first 10 observation, very simple, give 10 inside this. Okay, loan data dot head, 10 inside that. Then first 10 observation you can see. Okay. If you need by default first 5, just give that. If you need first 10, first 7, first 20, then give that number inside the head function. Okay, then if you want to see a snapshot of the last observations, what you can use is tail. Okay, for example, loan underscore data dot tail. Can anybody guess what will be the output? Head is the first 5 observation by default. Then tail will be yes, very good. Last 5 observations. Okay, last 5 observation. We can run that. Look, last 5 observations are there. If you want the last 10, just give that number inside. If you want the last 7, then give that. Then run it. It will work accordingly. So this is just a part of initial data exploration, like seeing the data snapshot from beginning and also from the ending. Okay. Now we need to find how many rows and columns are there in this data set. We need to find how many rows and columns in this data set. For that, again add a code cell. For that, you want to give loan underscore data dot shape. No brackets, just shape. Okay. Then run. You will get an output 598, 13. It means that our dataset has 598 rows and 13 columns. Okay. 598 rows and 13 columns. Columns are features or attributes. Okay. So, in order to find the shape, shape means the number of rows and columns, we can give the loan data, our data frame name dot the shape attribute. Okay. Now if you want to find structure of your data set, like more information about the data set, like what are the data types used or column names, etc. Some more detail, you can use info function. Before that, loan underscore data dot info. Okay, then run that. You can see some more details about our data frame or the data set. It says that our data frame and its data type is data frame. We already said that long data will be data frame. Data frame is nothing but a table-like structure. Okay, it lists out each column name, also the data type of each column name. Object means it will be text data. Okay, not numerical data, text data, categorical data. That means this object. Then integer in the 64 means integers. Integers means whole numbers, no fractional or no decimal parts. That is integers. Float means real numbers, numbers with point values, that is decimal places, that is float. So we are getting more information like the data type. Also we are getting count. In loan ID there are 598 observations. In gender column there are 598. Total how many rows are there? 598. So loan ID has no missing value. Gender column has no missing value. But when coming to this dependence, there is missing value. Why? Because total 598 rows are there. But for dependent column, how many only values are there? Non-null values, how many? 586. So something is missing in dependence column. Then coming to loan amount column, some values are missing. Then coming to this loan amount term, some values are missing. So by using this particular info function, we will get a information regarding the structure of the data frame or the data set we have. It also gives us a idea about how much memory it is using when we loaded it into the Python environment, and structure related information we get from this learn underscore data dot info function. Okay. Next, suppose we want to list out all the just all the column names only from this data set. Then we can use again give the code. Type it as loan data dot columns. Okay, then run it. Look, all the column names are listed out. Okay, loan ID, gender, married, dependents, education, self-employed, etc. So it is basically a checklist of every feature available in the data sets. Okay, from this loan data.columns, that is columns attribute, we can get a clear understanding of what the data we are working with, or what the input data means, input values, which one will be the input values, and also which will be the output value, and which all need to be encoded. Every detail will be getting from this info and also the columns function. Okay, from now for time being, we will be switching to a pre-coded format. That is pre-written code that have already means created before the session. Okay, this helps us stay focused on the concept, learning the concept instead of getting stuck with this typing time loop. Okay, so once you understand each step clearly, you can try rewriting the code on your own later. So let's continue with the pre-coded version. I am just closing this, and I have a pre-coded version here. The complete case study is here. Okay, I think you can see that. So the complete loan prediction case study is there. We will be looking one by one. Here in the there is a main heading is there, case study loan approval prediction. A subheading is lower. The subheading is very useful because you can section wise we can handle this. Look, can section wise group it also. Okay, very helpful. So when you are trying, use headings and section headings. Okay, so here we have only studied this import pandas as PV. There are so many libraries available. When we encounter them, we will explain what it means, etc. So for now, we have only studied what import pandas as PD. Okay, then we read the data set. We have using read CSV, we have loaded the data set. We tried the head function. We tried the tail function. Then we checked the shape of the data set. We checked the info of the data set. And we also have done columns of the data set. Up to this, we have done hands-on. From now onwards, we will be using the pre-coded form. You know that how to add this codes all and how to type it. Okay, so for time being, we will be using this case study code session. Okay, so here when we look at this column names, loan ID, gender, married, dependents, etc., you can see one of the column is not much important. Can anybody guess which is that? One of the column will not affect whether the applicant is approving the loan or not. Will not affect our case study. Which will be the column? Loan ID. Any other answers? Gender may have. We cannot say that gender will not. Yeah, loan ID is the correct answer. Loan ID. Loan ID, it is just a unification, unique identity number. So it will not contribute to whether the person will pay it or not. Okay. So for our scenario, loan ID is not important or not contributing to our case study. So we can drop that. So we need to remove the loan ID column from the data set. To drop the loan ID column, we have given this code. Look, loan underscore data dot drop which column? Loan ID column. And we are saying that x is equal to 1, which means that we are going to drop a column. X is equal to 1 means we are going to drop the complete column. So x is equal to 1. Then in place equal to true. In place equal to true means apply the change directly to the existing data set. So what we are going to asking Python to do is that in the loan data frame or the data set, remove loan ID column completely and reflect the change in the same loan data itself. Do not want to give any copy or make any copy of the data frame or data set. Whatever the change you are doing, change it in the loan data itself, in this data frame itself. That is why we are giving this in place equal to true. Okay, so in place equal to true means that the change directly to the existing data set. No need to create any copy. Whatever the change, please reflect that change in the loan data itself. So when we give this, what happens is that our loan ID column will be deleted from our data. Okay, now we will have only 12 columns. When we check loan data dot head, you can see that the first column loan ID will not be there in the loan data frame. Okay, so in this case study, I have added the comments below. Like this is also the text box. We can just add like this text box. Detailed explanations to understand it. Everything is added here. So after the session, also you can go to the points and rewind why it is done, what each code means. Everything is explained here in this case study, and also this is available in the LMS also. Okay. Now, suppose you need to understand a summary statistics of our data. Like you need to identify the mean, median, then what count, maximum value, minimum value, percentile, like statistical summary. You need to find the statistical summary of the numerical data. We can use this function, describe function. Okay, when we give loan underscore data dot describe, what happens is that all the numerical columns will be listed out. Look, This altogether 12 columns are there now, but only some columns are listed because these only columns are numerical columns. In these numerical columns, statistical summary will be given out. Means how many of them are there, the count of the values in that column, the mean value of that column, then standard deviation of that column, then minimum value of that column, then maximum value of that column, then percentiles of that column. Means 25th percentile, 50th percentile, 75th percentile. Okay, so many may be confusing what is this percentile. To understand that, these are the topics that we study in statistics in our plus 1, plus 2 classes, etc. I think. So to understand what is this 25 percentile, 50 percentile, 75 percentile, these are the values which tells how the values of each columns are distributed. For example, the 25th percentile means that 25% of data points are below this value, and 50th percentile means 50% of data are below this value, and 75% means 75% of data fall below this value. We can explain it by an example. For example, we can take this column, applicant income column. In applicant income column, we have seen 25th percentile. The other name of 25th percentile is Q1. Okay, Q1, we call it as Q1. Okay, for this 25th percentile, we can see 2877.5 is the Q1 value of applicant income. It means that the 25 percentile, also called the Q1 value of 2877 means, or it tells us how the incomes of applicant are spread out. That means the 25th percentile is the point where 1/4, that is 25% of the data lies below that value. That to make it simple, we can say that 25% of loan applicants earn below 2877. Okay, in this data set, the 25% of applicant earn below 2877. Then coming to 50% of applicants earn below 3806. Then coming to 75%, what 75% of applicant earn below 5746. Okay, so it will give us a distribution. We can find the how this Q1 or the 25th percentile, the 50th percentile, or the 75th percentile will give to help us in understanding the distribution of the data, where the lower value come, where the higher values come, etc. Okay, so remember that 25% is called Q1, 50% is called Q2, and it is also known as median, because this is the 50% means the middle value, right? So middle value is another name is median. So 50% means Q2, and also it is known as median, and 75% means Q3. Okay, there is an image also given here to understand it. This is suppose this is our complete data, then Q1 will be the first 25%, that is the Q1. Then first 50% will be the Q2 value, and first 75% will be the Q3 value, and complete will be the maximum value. Then this will be minimum value, this will be maximum value. This is Q1, this is Q2, and Q3. Remember, Q2 is the median. Okay, so also we will get the minimum value, mean, average value. Suppose here applicant income, in this data set, the average of applicant income is 5,292, and the standard deviation is 5,807, and minimum value is 150, maximum value is 81,000, like that. So we will get an idea about the statistical summaries about the numerical columns by using this describe function. Okay. Now we have inspected the data, we got an idea about the data. From this describe, we may understand that the ranges are very different. So we need scaling, and also there are categorical features. So we need encoding, and also we have found there are missing values in the info. Also we have found there are missing values present in the data. So we need a data preprocessing now. So first processing we are going to do is that we are going to detect and handle the missing values. Okay, so first to detect the missing values, give this code loan data.esnell.sum. When we run this code, what you get that for each column, number of missing values will be listed out. So for gender column, there is no missing value, so 0. For married column, there is no missing value, so 0. So here, for dependence column, there are 12 missing values. For loan amount column, there are 21 missing values. And then loan amount term column, there are 14 missing values. For credit history, there is 49 missing values. So there are some columns where we need to treat what missing values. So first, let us take one by one, and we can handle the missing values. First, we can take the dependence column. So as we know that dependence means the column dependence tells us how many people depend on the loan applicant. Okay, how many people depend on the person who applied for the loan. Then what do you think? How you will feel? Whether you use mean, median, or mode? Any guess? Our column is dependents, number of dependents, and number of dependents has missing values, and you know what is that column means. Then what do you think? How to handle that? Either we need to replace with the mean, median, or mode. Mean. Any other answers? Just guess. We need to fill that. That is must. We cannot drop it out. Dropping is not a standard method. But if we need to impute that. We said that 3 types of impute are there. We shall take marriage status in consideration for doing this. I didn't get it. Could you please explain, Krish Gupta? Others please put what? Mean or median or mode. Aparna is saying median. Okay. Will be fine. Let's look. What will be the better one? No. We no need to check if it is married or not. We are just going and directly filling. Okay. Here. So this is number of dependents, right? Number of dependents will be a integer value, whole number value. Okay. I think you understand what is this dependent column means. Dependent column tell how many people depend on the loan applicant. Means how many people are dependent on the one who applied for the loan. Is there any 2.5 people or 2.7 people or 2.9? Any decimal people come? No, right? The integer will either 1, 2, 3, 0, 1, 2, 3, or 5. Like integer values or whole number values will be there. When we find mean, when we find median, we may be getting point values 2.5, 7.5, 3.5, but that is meaningless in number of persons, right? So the best method here to replace the missing value is replace it with a mode. Okay, so I repeat, dependent is not a number we will average, it is a category. We don't have any 2.5 or 4.5 real number of persons or number of dependents. So we have distinct categories as dependents like 0 dependents or 1 dependent or 3 dependent, 2 dependent, etc. So because of this dependent column being the categories, like distinct categories, using mean or median would be meaningless. So the correct approach is mode. So this code, what we are doing is we are going to find the mode of that particular column, and then we are going to replace the missing value with the mode we found in that particular column. Okay, it's very simple. So to fill the missing values, the function used is fill. Okay, so in by which value we need to fill? We need to fill with the mode of that particular column. So what we are finding? Mode of that particular column. This is the mode finding code. Loan data dependence columns mode. So we are finding loan data of dependence dot mode of 0. So we are saying to the computer or the Python that take the dependence column and find the missing values in the dependence column and fill that missing values with mode of the dependence column and save the entire process in the same column. This is the meaning. I repeat, in this code, we are saying to Python that take the dependence column. Just the one data and column name in the square bracket. So take the dependence column, find the missing values, missing places in the dependent column, and fill that places with the mode of that particular dependent column, and then save the entire change in the dependence column itself. Okay, so this is how we are filling. Fill NA means fill null values. Okay, so fill NA function is used here to replace the missing values in the dependence column. Now coming to the next missing value column is loan amount term. Loan amount term, what do you think? Mean or median or mode? Mean. Loan amount term. What is loan amount term? Loan amount term is the for how many months the loan will be repaid. For how many months? Okay, generally banks give how many months as distinct numbers, not average numbers, like 160 months, 360 months, 120 months, not 120.5 month, not like that. Okay, it will be distinct values. So the better method will be mode. Aparna is correct. Mode will be the better one. So here again we repeat the same step. Okay, look. Now here refer the loan amount term column. Fill the loan amount term with the mode of loan amount term column and save the entire change in the loan amount term column. Okay. So same code, what only the change? The change is in the name of the column. Okay. Then coming to loan amount. Okay, next column we found missing is that loan amount. Loan amount, what do you think? Mean or median or mode? What method will be better to fill? It is a loan amount. The amount the one applicant need to borrow. Okay, amount. It is a money that a Canadian. Any other? Yes, either mean or median will be better, but most appropriate is median. Let's look why. Uh, Suppose, imagine there is a class of 10 students, and in that class, 9 students, the total students is 10. Out of that, 9 students got marks around 50. Out of 100, around 50. Some got 49, some got 30, some got 20, some got 21, like that. Around 9 students got marks below 50, and only one student got 100 out of 100. If we find the average or the mean of that class, we will get a value close to 100, right? There is one extreme performer in the class, so when we find the average mark of that class, there is a chance that the average will be close to 100. That average does not represent the true mark of most of the students in the class. Okay, so there is such problems in we encounter when we use mean. There are some cases it will not affect. There we can directly use this mean method. But when we use median, this problem is not there. Median will give exactly middle value. When arranged in an order, the median will be the exactly middle value. So the high mark of 100 does not affect the median. Exactly the same things happen for the loan amount. Many people may request similar loan amounts, but if one person, suppose some have only what 50 lakh, 30 lakh, 25 lakh, only that much. But suppose one have applied for a huge loan amount, 2 crore, 1 crore, like that. Then if we use mean there, it may be misleading. Okay, so it will be better in such cases when there is a unexpected behaviors or unexpected values are there. In such cases, the better method is median rather than mean. Okay, so to fill the median in the missing places of loan amount column is again the same code. Here we need to find the median, not mode. Okay, we are finding the median of the loan amount column, and we are filling the missing values of loan amount column with the corresponding median, and we are saving it to the loan amount column itself. So don't worry, all the simple what points to refer is added in this case study. You can also refer it further. Okay, now the next column having what missing value is credit history. Okay, credit history. What do you think? What is credit history? What will be the better one? Mean or mode or median? Credit history column. Its value is 1 or 0. 1 means good credit history. He is having a good credit score. 0 means he is not having a good credit score. Then it has missing values. Then which will be the better option? Mean, median, or mode? Yes, correct. Mode, because it is category. So better will be mode. So we have created the same mode code with the credit history column. Loan data credit history dot fill NA, loan data credit history dot mode. Okay. So by this we have handled all the missing values, and we are now going to check again if there are any other missing values are there. So again that same code I have given here, loan data dot is null dot sum. Now look, all the column values are with 0. It means that there is no missing values in this data set. We have handled the missing values in this data set. Okay. Now the next step we need to do is encoding the categorical values. This is very important. We know that our dataset has 12 columns. Around that, many of the columns are categorical, like male, female, graduate, not graduate, yes, no, like that. Text values are there in our dataset. So we need to convert that to numerical values. That process is known as encoding. So here what we want to do is that we are planning to label encode gender column, education column, married column, self-employed column, and loan status column. Okay, all the 5 columns has label and go, because these columns only have 2 distinct values, either graduate or not, yes or no, or male or female. A number of distinct values are less. So for uh, gender column, married column, then what? Self-employed column, loan status column, and education column, we are planning for label encoding. But for property area column, you can see that for property area, there are 3 distinct values coming: rural, urban, and semi-urban. So we are planning one hot encoding for property area, and for other all columns, we are planning label encoding. Okay. So first we can label encode education column. So as we all know, education column has 2 different distinct values: graduate and not graduate. So before we encode the categorical features or the text to the numerical value using label encoding method, we need to first load the label encoder library. So that code is given here, this one. From sklearn.preprocessing, import label encoder. Okay, this line or this code says that from the scalar library, in that preprocessing module, please import label encoder. Okay, for what? We need to encode categorical features to numerical features, that label encoding technique. For that, I need this library. So please import that. So at this moment, please remember that sklearn is the most important machine learning library in Python. It is also known as scikit-learn. Okay, I can show you. So this scikit-learn. sklearn complete form is scikit-learn. So it is the most important machine learning library in Python. In that library, there are many functions for all the operations, for encoding, scaling, model building, the algorithms. All the algorithms we are going to study will be there in the sklearn library. So remember that sklearn library is the machine learning library in Python, and pandas library is the data manipulation or data analysis library in Python. Remember that. So we have loaded the label encoder library. Now come to our coding part. First, we are going to encode education column. So before encoding, first we need to create a label encoder object. Very simple, LE equal to label encoder. Here we are asking Python to create a label encoder object. Then using that label encoder object, fit transform each column. So here in this code, in this highlighted code, loan data of education equal to fit underscore transform loan data education, means that we are asking Python to encode the categorical features in the education column to numerical values, that is LE is a label encoder. So to numerical value by the technique called label encoding, and please say or please reflect the change in the education column itself. Okay, so I repeat, I am asking the Python to label encode the distinct values in the education column to numerical values and reflect that change in the loan data education column itself. So once I run this line, what happens is that the distinct values, the text values in that column will be converted to numerical values. So if we want to know which value is encoded to which numerical value, which number, we need to know that, right? For that, you can use this one, le.classes underscore. le.classes underscore. When we print this le.classes underscore, you will get this output like graduate comma not graduate. It means that in programming, remember that in programming language we start counting from 0. Okay, so graduate is in the 0th position and not graduate in the first position. So graduate in 0th position, not graduate in the first position. The counting will be always from 0, 1, 2, 3, etc. You may have seen that when we look our data set counting also 0, 1, 2, 3. In computer science, in mostly every programming languages, the counting will be from indexing. We call it as indexing. It is from 0 to n minus 1, like that we are going. So what this means is that after the label encoding technique of the applying label encoding technique in the education column, the graduate is mapped as 0 and not graduate is mapped as 1. So the position will be the encoded number. Okay, I repeat here what this any classes underscore give the what says to us is that graduate is in the 0th position. It means graduate is encoded as 0 and not graduate is encoded as numerically 1. Okay, graduate numerically 0 and not graduate numerically 1. Okay, repeat the same process for all the other columns. Launch status, again, use the label encoder object, fit to transform, launch status. Here, in Y, if I put this output in the chat box, which is 0, which is 1? Can you guess which is 0, which is 1? Which text is encoded as 0 and which is encoded as 1? Yes, correct. N as 0 and Y as 1. So you got an idea. So repeat this for every column. So gender column we have done that. Female as 0, male as 1. Then married column again. No as 0 and S as 1. Then self-employed column. It is also having distinct values S and no. So no as 0 and S as 1. So after all the steps are run, when we check the snap of our data using the head function, you can see now the gender column has been encoded, married column encoded, education column encoded, self-employed column encoded. Then what? Our property area is still there because we haven't handled that, and launch status also encoded. Okay, 1 means yes and 0 means no. So launch status also encoded, but we haven't touched this property area because if we label encode this, it may be like suppose rural is 0, urban is 1, and semi-urban is 2. Then there is a magnitude or ordering problem will be there. So we can one hot encode this property area. Okay, to one hot encode this property area, it's very simple. Just give pd.get dummies, the data frame, and the columns you need to one hot encode. Okay, I repeat, pd.get dummies. Then first give the complete data set you need to apply the one hot encode. So the complete data set is in the one data. And which columns you need to one hot encode. We only need one column to one hot encode. So I have given only one column. If you had so many columns, put the comma and give that column name. Okay. So in our case, there is no other columns. So only our property area is there. So I have given only property area. So here it is saying that please take the long data set, and in that property area column, get dummies of that is one hot, and please one hot and go that data that column and reflect that change in long data itself. Okay, reflect that change in long data instead. So yesterday we have seen when we one hot and good. I think you may be remembering that our example, chicken, broccoli, and apple. Each value will be a new column, and if there is their presence is there, there will be one, other will be 0 like that. We have seen yesterday, right? So that exactly what that will happen here. But here there is an change. Look, 3 more columns have been added. Look, property area rural, property area semi-urban, property area urban. I have just given the head here to display the first 5 observation. Look, so okay, property area rural, property area semi-urban, property area urban. Here instead of 1 and 0, true and false is given. Okay, true means 1, false means 0. True and false are the Boolean data type. Numerically, Python understands it as true as 1 and false as 0. So when we read or when we understand this false as 0 and true as 1, exactly as 1 and 0 notations or binary representation is done here. So each distinct value came to a new column, and according to that position of the occurrence of the particular column, true came, because first data was urban. So under urban, true came. Okay, others will be false. So this is the output of the one hot encoded data. Now our data set have completed the encoding technique. We have label encoded some columns and we have one hot encoded the next column. Then what is the next step we need to do? Can you guess from the session yesterday's? What is the next step? We have completed missing value. We have completed encoding. What will be the next? Yes, correct, Vinaya. Scaling. Scaling is the next option. Next step in the pre-processing. So here, scaling the features. You know why we are scaling, what is the importance of the scaling, etc. You know that. Because in our data set, you can see, look, some values are zeros and one. Some values are very huge amount. Okay, some is 3-digit numbers. So our data is not in a scale. Okay, there is issues. So if we give this data to our model, our model may think that applicant income is important than self-employed or education. Like that, there is a indirect importance will come. So in order to avoid that, we need to scale whole or the scale the higher value column in our data set. For that, we are using standardization or normalization. Yesterday we have seen the formula that value minus mu by sigma. We have seen some examples, etc. Same thing is happening here. For that, we need to use standard scalar. Okay, standard scalar. So in order to use standard scalar, first we need to import standard scalar from sklearn library. So go to the top. It's important. Look, from sklearn.preprocessing, import standard scalar. So we are saying Python that please import standard scalar library from the sklearn preprocessing module. So after loading that, laterally we can run the standard scalar object. Okay, so here exactly what we done for label encoder, here also we need to first create the scalar object. So okay, standard scalar, we are creating the object and we have named that object as scalar. You can give any name, okay, my scalar or long scalar, any name you can give here, but this is the object creation code, standard scalar. So we have created the object. Using that object, we need to fit to transform each of the column that we need to scale. So first column I am taking. I am asking Python, hey Python, take this applicant income column and using the standard scalar, please transform it. Means when I say this, what the Python do is that it will take the applicant income column, it will find the mean of that column, it will find the standard deviation of that column and take each value, then each value minus mean by standard deviation. What we have seen yesterday, that operation will be done and that change will be reflected in that column itself. Okay, the same process is repeated for co-applicant income, loan amount term, and dependence. Okay, these are all values are, other values are zeros and ones. So we are not scaling that, we are scaling values with a different magnitude. So all the columns we have scaled and we are just looking for what hit, that is our first 5 observation. Look, you can see that dependence is now between -1 and 1. Look, applicant income is got scaled, co-applicant got scaled, loan amount got scaled, loan amount term got scaled, and also there's no issues because Python compiler by itself what convert true as 1 and false as 0. We only seeing this as true and false. Inside the compiler it is true as 1 and false as 0. Okay, now our standardization or the standard scaling method is complete. We have scaled our feature. Now the next step is, what will be the next step after scaling, or what after the preprocessing? What is the next step we have learned? Yes, correct. Split the data set into train and test sets. Correct. So we are going to do that. Okay, splitting the data set. So before splitting, what we want to do is, we need to separate the input variables and the output variables. Okay, we need to separate the input variable and the output variable. Output variable is very simple. Output variable is what we need to predict. That is the output variable. So here what we need to predict? The launch status. We need to predict the launch status. So our output variable is, output column is launch status. Our input columns are all the other columns like gender, applicant, income, co-applicant, that is except launch status. All the other columns are input columns or input variables or input features, and we have only one output column, that is the launch status column. Okay, so we need to separate this input columns into x value, x variable, and output column to y variable. This is the first step we need to do before splitting. So look, I have taken the launch data frame, and I just dropped the launch status column, just dropping that launch status column, and I am saying that please copy that into x. I haven't given in place equal to true here. Remember, if you give in place equal to true, what happens? That dropping will affect this launch data. So I am saying that do not affect this launch data. I need this launch data later. So what we want to do is take the launch data frame, drop the launch status column, and just copy that to the variable x. So x now contains all the columns of the data except launch status column. So x is our input features. Okay, now I need to copy the launch data, that is the launch data launch status column, our output column, to y. For that, it is a single column, so there is no issues. Just refer the column and assign it to y. So if we split it into train set and test set, we will get 4 groups, right? We will be splitting x to train set and test set. We will be splitting y to train set and test set. So in total, we will be getting 4 groups, and it will be x train, x test, y train, y test. Okay, I think you got an idea. We have separated the x values and we have separated the output y values. Then we are going to split. So now when we split, you will have 4 groups, that x will be having training and test, y will be having training and test. So we have, after splitting, we will be having 4 groups like x train, x test, y train, and y test. Now we are going to split. In order to split, we are using the function train underscore test underscore split. Okay, to run this, we need to import the library, and the library is imported at the top. This is the library. From a scalar.model selection, import train underscore test underscore split. So after this importing only, you will be able to run this splitting step. Okay. Okay, this is the splitting step. First, in the splitting function, first you need to give the input variables, that is your x. Then you need to give the output variable, that is your y. Then third argument or third parameter you need to give is test size. Test size equal to 0.2 means that it says Python that your test data size is 20%. That if you have the data set, please take 20% of data for test set and 80% of data for train set. If we give it as 0.3, what happens? 30% of data as test set and 70% of data will be as train set. So we are going for 80-20 proportions. Okay, so we are going to split x input variable along with y output variable, and we have given the test size 0.2. Now we have given something like random state equal to 42. So here you need to understand why we have given this 42. Okay, when we use random state equal to 42, the number itself is not very special. We can give any number there, random state equal to 1 or random state equal to 10, random state equal to 100 or 120, 25, any number you can give there. The purpose of random state is simply to make sure that the way the data is split into training and testing test set stays the same every time we run the cell. So if we run this cell for 10 times, then for the 10 times I need the same test set and same train set. For 10 times, if we are getting different test set and different train set, it will affect the evaluation of our model. We cannot stick on that, or we cannot get any conclusion about which model is greater, what's good or not. So whenever we split, we need to get a stable or same split, same train set and same test set. For that, we are giving this random state equal to 42. Okay, I repeat, random state is simply to make sure that the way the data is split into training and testing set stays the same every time we run the code. So without setting it, the split changes every time or each time we run the cell, which can make the model result may be varying. Okay, the setting a random state is like giving the computer a shuffle key. So if you use the same key, same number, the data will be shuffled in exactly the same way every time. If we change the number, we get a different shuffle. So here I have used 42. You can use any numbers, and based on that number will be the shuffling will be done. So for each run, the shuffle will be same. We will be getting a constant or constant X train and Y train data sets, and also 4 sets will not be shuffled for each run. So this helps us keep our result stable and also repeatable and also easy to debug. Okay, so in this line, what we have said to the Python that please split input X and Y with this test size, that is 80% to train data and 20% to test data without randomness. Okay, now I have printed the shape of X train and Y train, X test. So X test shape is 478, 13 and X test shape is 120, 30. Because 80%, we already had 598, around 598 rows. 80%, that is 478 going to X part, training part, and around 20%, that is 120 going to whatever test size, that is test part. And our column is 13. Why? Because after one hot encoding, we had 3 new columns. Okay, so the count is 30. So there is a image also given here to understand this process. First, the data set was complete in fully in our session, and then what we did, we just splitted into or divided into X and Y, input features and the target output value. Then we splitted. After splitting, we got X train, Y train, and X test and Y test. Now using this X train and Y train, we will build the model, and using this X test, we will test the model. That is what we are going to do. Okay, so we have successfully splitted our data set, and next step is the model building part. So this is the stage where we allow the machine learning to learn from patterns. That is the model building and evaluation part. So in order to do that, we need to study different algorithms. Okay, in this webinar, we will be learning 3 important classification algorithms, that is SVM, support vector machine. Then we will learn KNN, k nearest neighbors. Then we will look into decision tree in the coming classes. So each of these algorithms has a different way of learning patterns from data. So SVM tries to draw boundaries, KNN will be looking similarities, and decision tree will be forming rules or tree-like structures. So from day 3 onwards, we will begin with support vector machine, and we will uh, look at how the SVM works, how to train it, and how to improve its accuracy. After that, we will continue exploring the remaining algorithms in the upcoming sections. And our goal is to build a model to predict whether to approve the loan or not. Okay, so before we wind up today's session, let's quickly have a quiz session exactly what you have done as yesterday. Okay. Okay. I hope you can see the screen. The first question is there is a data set given here: age, salary, gender, purchase. Then looking at this data set, which columns have missing values? A, age and salary; B, salary and gender; C, age, salary, gender; only gender. Which columns have missing values? A, B, C, or D? Put it in the chat box. Okay, just look it and put it in the chat box. Yes, option C, age, salary, and gender. Here also one question mark, here also question mark, here also question mark. So three columns have what? Missing values. Good. Now for the salary column, we have missing value, right? So which method is suitable to fill missing values? Mean, mode, or median? Or ignore the missing value. For the salary column, in order to fill with the missing values, what is the best approach? Mean, mode, or median? Okay, see, median. Yeah, median is the greater one because mean always have the problem of that. Always remember the class example. Somebody scoring low marks and the one who is scoring 100 out of 100. Okay, such cases is also applicable for salary column also. So median will be better. Okay, good. Now, how should the missing value gender could be handled? Mean, median, or mode? Just to say that. Mean, median, or mode. Column is gender. Mean, median, or mode. Column is gender. Yes. Mode. Mode. Correct. Mode will be the better one. Good. Because it do not have any average or decimal values. It is a categorical value. So mode will be better. So at what stage, next question, at what stage should missing values be handled? Before splitting or after splitting? When we need to handle this missing values? Before splitting the data set or after splitting the data set? Just to give before B. Okay, B means after before splitting the data set. Very good. Now another, the dataset contains age ranging from 20 to 60 and salary ranging from 20,000 to such a huge amount. Like then, why scaling is required? To remove missing values, to convert text to numbers, to bring features to the same range, to increase dataset size. Which will be the option A, B, C, or D? Why scaling is required? Okay, why scaling is required? To track that, I will put the question here. To convert text to numbers, B. Age is a numerical column, salary is also a numerical column. Why scaling is required? Scaling always done to a numerical column, right? Yes, C. To bring features to a similar range. Correct. C is the correct answer. Scaling will always will be done to the numerical columns. Okay, encoding is what? Text to numbers. Converting text to numbers is encoding. Scaling, the aim of scaling is to bring features to a similar range. Okay, fine. Now, last question. You have this data set with 1000 records. Okay, you use 800 for training and 200 for testing. Then what is the split ratio? Total records are 1000, 800 for training and 200 for testing. What is the split ratio? 20 30, 15 25, 20 80 20. What is the split ratio? 80 20. Okay. Total 1000, 800 to training, 200 to testing. Then what is the split ratio? C. You have seen that. C, A, B, C. 80 20. C. Okay. Yes, 80 20. 80% of 1000 is 800. 20% of 1000 is 200. Then what will be the test size value we need to give in train underscore test underscore split? That function. What is the test size value? We need to give test size equal to what? Yes, 0.2. Yes, great. If we want to get 70-30 proportion, what will be the test size? Yeah, 0.3. Good. Fine, fine. Okay. So, alright, everyone, that's it. We have officially reached the end of today's session. You all did really well. Okay, so even if some steps felt new or a bit confusing, don't worry at all. With practice, everything becomes clearer. Okay, so make sure to try this case study on your own. You will find all materials, references, and today's recordings in the uploaded in the LMS. Okay, by tomorrow morning, everything will be uploaded in the LMS. The more you practice, will be more the stronger of your understanding and more you will get your skill. Okay, so remember that our next session will be on December 12th at 7 p.m. Okay, December 12th. Our next session will be on December 12th, and on that day we will dive into SVM, that our first algorithm, support vector machine, and we will try that support vector machine in this our long case study. Okay, so before we wrap up today, I will share the feedback form. Please take a moment to fill the feedback form, okay, as you do in every sessions. Okay, please take a moment to fill this feedback form now, and also if you have any queries, please put it now in the chat. If you have any doubts or any queries, please put it in the chat box. Others, please fill the Google form. Okay. Please note that this feedback link is also available in the LMS. So please ensure to fill the feedback form. Okay. If no more questions, we can conclude for today. Thank you so much for your energy and participation throughout the class. Okay. Starting from the next session, we will officially build our model building journey, and we move deeper into machine learning, including prediction and evaluations. Okay. So see you all in the next session, and remember on December 12th, Friday, 7 p.m. Okay, December 12th, Friday, 7 p.m. So thank you once again and happy learning. Bye. Thank you.